finally landed in Mars. Girl Gang Gourmet is now establishing their Martian Munchies company. The first measurement we need to take is temperature sensing. And as CEO, I will oversee this great team and be able to collaborate and manage a project to get that done.
As a co-compliance wrangler, I'm excited to get started on our Arduino with the C-script code.
Well, as the builder, I'm really excited to figure this out, see how I can get it into our building.
As a detailer, I'm really excited to pick through all of the requirements and make sure we have set everything on that.
As the media manager, I'll make sure to document all the journeys we do on Mars.
And of course, as someone in charge of safety, I'm going to make sure everyone's keeping safe and up to standards.
Well, this seems like we've got it all covered. I can't wait to start on our temperature sensing.
Go team!
Go team!
Yeah.
Hi guys, it's Ayana.
It's Gabby.
And so we're doing the pre-narration. So the main thing we're measuring is we're going to be measuring the temperature of the food and the indoor climate of the restaurant.
Why are we measuring this? We're measuring this because temperature is a crucial component of our food as a restaurant chain. We need to make sure that it's not overcooked, that it's not raw, that it's just right for both Martians and Earthians in our restaurant.
Right. And so we will be using different colors to make it easier for the employees to determine whether the food needs to be cooked on the stove longer or if it's just right or if it's like a little overcooked. So that would be helpful for the employees.
Yes, different colors. We're also planning on using an LCD of some type, which is liquid crystal display. So we'll be able to display this as well for any confusion, new employees, things like that. This will be a very unique code.
Right. All right, signing off. It's Ayana.
Bye.
Bye.
Hey again, it's Ayana, and I'm going to be explaining to you what we did as Girl Gang Gourmet for this project. So on the left you can see Karina and Bella working on the code. Karina's screen is on the left and Bella's screen is on the right. In the middle there's Daria and Darcy. They're working on the schematics of the project, and Gabby and I are working on the document for submission and making it easier for everyone to read, assigning the roles for each video, and making the video more interesting. Bye!
Okay, so we were able to incorporate these three LEDs corresponding to different colors to our different temperature ranges. Blue means that it's too cold, red means that it's too hot, and green means that it's just good. Is there any ideas of how to make this better?
I mean, how do we make it more user-friendly for the employees to use?
Well, if you think about it, wouldn't it be better if we displayed something? Is there some kind of component for that?
Oh yeah.
Okay, I've seen something, I've coded with it before, the LCD, the liquid crystal display, so that the user can see whether it's cold, hot, or good. Doesn't really have to see the temperature.
Oh, that would be good. Yeah.
Like a text message so that they can visibly see it?
Yeah, exactly, yeah.
And it's not that perfect, just in case they forget the colors too.
Oh yeah, that's a good idea in case it's like a new employee.
Yeah, that's perfect, and I can get started on the code right away.
Okay. Right.
Perfect.
You're right. So one of our problems was that we have the right code now, and our code works, and it should display what we wrote onto the screen. However, when we actually put the wires themselves don't work and it's not transferring into the circuit.
We likely have to change it to alligator wires, which we were thinking about using before, but we weren't sure if we had to. So we're gonna search up which wires need to be alligator wires and which wires need to be regular wires.
We're gonna start the simulation, and here's our LCD screen. This is the wirings I used. I hooked up this side to the positive and negative of this one into a 5-volt port. And when the temperature reads anything below 60 degrees Celsius, it prints too cold on the LCD screen. If it's just between 70 and 75 and 60, then you can even see on the serial monitor, it's showing the different temperatures, which this is between 60 and 75 degrees Celsius. So the screen is printing ready. and if it's anywhere above 75, the screen prints too hot and this red LED comes on. Red LED is for too hot, green LED is for ready, and blue LED is for too cold, and each one is displayed on the serial monitor every 500 milliseconds.
For our project, the key component was the temperature sensor, which is located right here. The temperature sensor's analog output pin was connected to the A1 of the Arduino, and the VCC pin was connected to the 5 voltage on the Arduino, which is located right here. And the ground pin of the temperature sensor was also connected to the ground pin here. The NeoPixel, which is found right up here, was connected to the signal pin of the NeoPixel was connected to the pin slot number 2 of the Arduino, and the VCC of the NeoPixel was connected to the 5 voltage as well. The ground of the NeoPixel was also plugged into the ground here as well, and the LCD, which was the liquid crystal display, which is found right here, has multiple pins. The RS pin 12 was connected to the pin 12 of the Arduino. E of the LCD was connected to pin 11. D4 on the LCD was connected to pin 5. Pin D5 of the LCD was connected to pin 4. D6 of the breadboard was connected to pin 3 on the Arduino. D7 was connected to pin 2. The VSS was connected to the ground. VDD was connected to the 5E here of the 5 voltages here on the Arduino. 5O, which is a contrast control, was set between 5 volts to ground. And the A, which is the backlight, was pinned to the 5 voltages as well, and the K backlight, which was the negative, was connected to the ground, which you can see here. It's connected to the negatives. And so then the LEDs, the red LED, which is right here, which is for too hot, was connected to pin 10 and connected to ground. And in order to balance out how much voltages was going through, we had a 330 ohm resistor. The 330 ohm resistor is found throughout for each of the LEDs. Even the blue LED, which was connected to the 8 pin, and the green pin, which was connected to the 8 pin. So overall, our project would be connected through the power source, which would be a USB in person. However, since this is on virtual, everything is just...
I set up the LCD, the Arduino, the NeoPixel, and all of the LEDs, and then connected them to our code portion using first defining each one. The NeoPixel, the pin it uses, the liquid crystal display, and then I started to create variables for the different temperatures conversions, either for Fahrenheit or Celsius, so that way it can be displayed on this serial monitor here. So every time we do the working demo, it displays the temperatures on the serial monitor. And then I created integers, variables for all of the LEDs and labeled them red, blue, and green. Based on the temperature ranges, the blue LED ranges anywhere from 0 degrees Celsius to 60 degrees Celsius, and the green ranges from 60 to 75, and the red ranges from 75 to I think 100. After I did that, I defined which pin they were in the Arduino. I set up the liquid crystal display, defined its measurements, how many LEDs it uses, and exactly where its pins are. Right here. And then I use the pin mode and define the LCD, and then all under a loop statement, all under a loop statement, I use the temperature conversions to convert between Celsius and Fahrenheit, depending on the temperature that the temperature sensor read. And then after I did that, I would reset the serial monitor every single time it would retake a temp. It takes a temp every 500 milliseconds is the delay I set. I would put everything in an if statement. So if the temperature was below 60 degrees, then it would correspond to the blue LED. The LED would light up and all of the other LEDs, the red and the green, would come off. And then the LCD would print too cold. An else if statement I used was for the medium temperature or the green temperature, which was between 60 degrees Celsius and 75 degrees Celsius. So if the temperature sensor using the conversions I defined previously would sense a temperature between 60 and 75, then it would print out on the LCD screen ready, meaning that the temperature of the food was at optimal range. And the green LED would be the one turned on, and all of the other LEDs would be turned off. Finally, I defined an else statement right here for the red LED, which would be an indicator that the temperature was too hot or above 75 degrees Celsius, because that would burn people's mouths, and it would print too hot on the LCD screen. The red LED would be the only one that would be turned on, and all of the rest would be off. And finally, I set the delay to 500 milliseconds. That way, it's not constantly reading the temperature. It's just reading it every 500 milliseconds, because I felt like that was the right timing, and the serial monitor wouldn't have to be filled with a bunch of temperatures.
Hi, I'm Darcy,
And I'm Daria.
and we are doing the
Post-narration.
We are doing the post narration. So, in that, we have to talk about the components, what we used, why we used them, stuff like that. So, of course, we had to use the breadboard. We have to build our circuit without soldering, and it's pretty straightforward stuff. Makes it really just easier, and then we can reuse the parts if we have to. Of course, it's virtual, so don't have to worry about that. It serves as a main platform to connect all the parts. The wires, our sensors, our LEDs, stuff like that. You want to do the wires?
Yeah, sure. And then after the wires, which are what we're going to use to connect all the parts together, we are going to use the temperature sensor to sense the actual temperature, which that's going to be our input into the code in the system that we're using. So the output for that is going to be the LED lights, which the blue light is going to represent if the temperature that we have set is too cold for it, then the red light if it's too hot, and then the green light is going to represent the desired temperature that we have set for the food.
Yeah, and so that's going to work for the food as well as the general temperature of the restaurant, so AC and stuff like that.
Yeah. So we are also going to be using a display to display the actual message saying if it's too hot or too cold, because not everyone can know what the actual colors mean. For example, if we get new employees and stuff like that sometime in the future.
Yeah. So the display will be able to show Celsius and Fahrenheit, just to make it easier for whoever shows up.
Mm-hmm.
And then what we learned about the project.
Yeah. So what we learned is basically how the inputs will change the way the outputs are going to come out. For example, if the temperature is below, for example, 60 degrees, it is going to be blue because, hey, that's too cold. The food is not ready yet. If it's red, then that means the food is too hot. It's above 75 degrees Celsius. And that's hey, it's overdone. That food is not good to eat.
Yeah.
Yeah.
We also learned just how to use the virtual Arduino. For all of us, I believe. It was our first time using it. We had to learn how the buttons worked, stuff like that. And so it took us a little while to get the hang of that, but we feel like now that we understand it, next time it will be more efficient.
Yeah, and show them the schematic.
We have a time lapse in our video of a schematic, but this is it.
This is the finished one. Here. There you go. There you go.
is for our temperature sensor. Just shows all the parts.
Yep.
And you'll hear more about that from Bella and Karina.
Yep.
All right.
Okay, so this is our working temperature sensor.
Yeah, I can look at it.